While we are highly trained professionals dealing in complex mathematical procedure, we do encourage you to try this at home as it will hopefully enhance your mathematical understanding. So welcome back to 1 Lesson 3 Math. Here we are with another 10 minutes, 10 marks video. So we have 4 questions on a range of topics. If you would like to have a go at the questions, please pause the video now before I proceed with the solutions. So number 1, Kathleen drinks a lot of coffee. She records how many coffees she has per day over a 50-day period. And we've got the data in the table there. Now you can see that we've got class intervals and it doesn't specify the exact data. So what the table is telling us is there are 19 days where she has greater than but less than or equal to 5 coffees. There are 21 days where she has more than 5 coffees but less than or equal to 10 coffees, and so on. So we can't get the exact mean because we don't know the exact number of coffees she's had. However, we can estimate the mean, and this is what we have to do in part A. Now, to do this, we need to find the midpoint of each class interval, and we need to multiply that by the frequency. So that gives us an estimate. 19 days where she has between 0 and 5 coffees, the best estimate is 2.5 because it's exactly in the middle, it's the midpoint. So, midpoint times frequency is how we're going to go about doing this question. We're going to do, first of all, 2.5 times 19, which is 47.5. 7.5 times 21, which is 157.5. The next midpoint, because it goes from 10 to 20, is 15. So we're going to do 15 times 7, which is 105. And then the final midpoint is 25. Multiply that by 3, we get 75. So we need to total up the midpoint times frequency. We also may need to total up the frequency, though it does tell us that it's a 50-day period. Just to check, yes, that does add up to 50. A common mistake here, by the way, would be to divide by 4 because there's 4 rows, but you do need to total up the frequency. So to estimate the mean, we'll total up our midpoint times frequency. That is 385. So we're going to do 385 divided by 50, and that gives us 7.7. Now you look at your data and you think, is that a suitable mean? The data is between 0 and 30 coffees. I mean, I would not recommend having over 20 coffees per day, by the way, but maths questions are maths questions and they can be a bit extreme. But basically, most of her data is around 0 to 5 coffees and 5 to 10 coffees. So 7.7 seems like a suitable answer. To write down the modal class is the one that has the biggest frequency. And the biggest frequency is 21. So the modal class is greater than 5 coffees, but less than or equal to 10 coffees. So that would be the points for the first question. The second question is a simplification of an algebraic expression. I'm going to deal with the numerator and the denominator independently. So we've got 6x squared plus 36x. Now, I need to factorize here. And with this kind of question, you're going to have something that you can eliminate on the numerator and the denominator. And that's how we can simplify it. So factorizing the top gives us, we're taking the 6x out. So it's going to be 6x, and in the bracket, x plus 6. Now, when you've got an x squared minus a square number, it's going to be x plus the root and x minus the root in the brackets. Now, 36, the square root of 36 is 6. So the factorization of x squared minus 36 is x plus 6, x minus 6. And you can see now that when we write that back as a fraction, x plus 6 and x plus 6 cancels out. So our simplification is 6x over x minus 6. And that would be your final answer. Question 3. Anne Frappology studies the origins and development of human societies and culture. That actually has nothing to do with the question, but she does have $6,000 to invest in a simple interest account that pays 5.5% interest per annum per year. How many years will it be before she has more than $7,000? Now, there's 2 ways of going about this. You could use trial and improvement, remembering that simple interest is 100% plus years times percent, and then you make your multiplier by dividing by 100. However, what we can do here is we can actually work out the percentage change, and that's going to be 1,000 over 6,000, because obviously the change we're looking for is from 6,000 to 7,000, so that would be 1,000. The original value was 6,000, so percentage change is change over original times by 100, so that is 16.6%. 6 is recurring, by the way. So we need to work out when she's going to have more than 16.6%. So for 3 years, it would be 3 times 5.5, and that would be 16.5%. So that wouldn't quite be enough. But for 4 years, 4 times 5.5% would be 22, and that would be the point where it would become more than $7,000. Just to check that, using the multiplier, for 3 years, we would do 6,000 times 1.165. Obviously, it would be 100% plus 16.5%. So 116.5% as a multiplier is 1.165. And that gives $6,990, which isn't more than $7,000. But for 4 years, the multiplier would be I'll just move things around a little bit so I've got some space to work. So for 4 years, the multiplier would be 1.22 because it's 22%. 100% plus 22% is 122%. 122% as a multiplier is 1.22, and indeed 6,000 times 1.22 is 7,320. That's more than 7,000, so our answer is 4 years. Question 4. Terrified has a sphere. In fact, he has lots of spheres. Part A, one sphere has a radius of 9 meters. Calculate the volume. So we need to use the formula that's given in the exam booklet. Volume of a sphere is 4 over 3 pi r cubed. So we just need to sub the radius into that to work out the volume. So it's going to be 4 over 3 times pi times 9 cubed. And that gives an answer of 3,054.628059. Rounding that to 2 decimal places, it doesn't specify the level of accuracy, so 2 decimal places is always a sensible level of accuracy. So our solution would be 3,054.63. Remember, the 2's got an 8 next to it, so it rounds up meters cubed. Part B, another sphere has a volume of 60 meters cubed. Find the radius to 3 significant figures. So we need to create a construct here. We need to set up using our formula. It's going to be 4 over 3 times pi times r cubed equals 60. You could write it like this. So we've got 4 over 3 pi r cubed equals 60. So now we need to rearrange this formula so that we can work out the value of r. So the first thing we're going to do is we're going to multiply both sides by 3 to get rid of the divide by 3. So 4 pi r cubed is going to equal 180. Then we can divide by 4 pi. So that gives us the radius cubed is 180 divided by 4 pi. Then I'm going to cube root that. So r is going to equal the cube root of 180 divided by 4 pi. So I'm going to put that into the calculator, and that gives me 2.4285. I'm writing down enough of the calculator display. Check the question. It says find the radius to 3 significant figures. So I'm going to round 2.42. That's my first 3 significant figures. The 2 has an 8 after it, so my solution is going to be 2.43 meters, and that's my radius. Remember, the radius is a length, so it's just meters, not meters squared or meters cubed. So they are the answers to question 4. So I hope that's been helpful, and check over it again if you need to go back over things to check that you have an understanding of how to do these questions. Hasta la pizza, Harry Verducci, so long, goodbye, we'll see you next time.